Let's take a look at the printer example in code. I'm going to open up Eclipse again and I have a little prepared example that we're going to start from. Let's start by taking a look at the printer and let's take a look at where in that printer we implement something related to queuing. As we look through the code, we see that in multiple places we are dealing with the print queue and the priority and how to get to the job. So for example, in this run method, we're calling get next job and remove job. We have a private method that gets the next job. We have another private method that removes the job. In addition to dealing with the queue itself, we obviously have the other jobs such as printing it, which is doing some translation and dumping the content onto a printer. And we have also other methods, like, for instance, something that converts the content of the job into some printer language, and so on. As we can see, the printer is implementing multiple concerns. What we want to do is to break out that queuing, but we'll do that later after we run through the example. I'll open up the main class, which is a simple test driver, and then we'll examine the code and explain what's happening. The first thing I'm creating is just a simple random object that I'm going to use later. And then we have a set of users that I've created. This is so we can simulate the jobs. I create a printer that I then start. Printer is a subclass of a thread, so I have to start it. And then I'm iterating through in a loop and creating jobs and picking a random users, setting some random content. And then finally, after we've created 10 jobs, then I'm basically shutting things down and it forces me to wait for a little bit until all the jobs have been printed. I want you to notice in main here that the client's job is very trivial. They have a simple printer, very simple interface, and they're not bothered with the fact that there are multiple queuing strategies, that we have to translate things into printer languages and so on. It's a simple printer. All they need to do is add a job to it and ask the printer to print something. Before I run the code, let me just explain the code here. The first thing was that we in the loop are calling this print method. If we go into this print method, we will see that this simple print method is basically just adding the job that we created onto a list that is called jobs in the printer class. When the job has been put into this list or this queue, the run method, this is where the main algorithm is. While we are supposed to run, we go and we sleep a little bit and then we pick up the next job. And if one exists, then we will print this job and then remove the job from the queue. Finally, we'll inform the user if the user is listening to something, if the user want to know when the job is done. If we now run this code, we should see on the output, the printer is accepting the jobs and then printing it out. So let's run it, and then we'll see the jobs being printed out. We can see they're being printed in order. It might look a little weird, but what I'm doing just to translate the actual content is I'm uppercasing it and then printing it out in reverse just to do something interesting. Now let's implement a strategy. And what we'll do is we'll break out the queuing behavior. And I'm going to start by creating a simple interface. And we'll call this interface for a printer queue. And a printer queue will be the abstraction that I want to separate out so that all the queuing behavior is in one place. So we need to define that queuing behavior. Perhaps we'll have a couple of methods, an add job method, and perhaps another method for getting the actual top job or the first job. Maybe it could return a job and then we'll get next job, and that could be the abstraction. Now we should document this and write a little bit of comment for it. So I'll write a comment for the add job and just say that adds a job to the printer queue. Then for the get next job, which might be a little bit more interesting, here we could say that we get the top job, and if there are no jobs, we could return null. So that completes our abstraction of a strategy. So now we have a queuing strategy that we want to extract from the overall printer implementation and put into a separate hierarchy where this printer queue is the interface or the abstraction of the concern that we're breaking out into a strategy. So before we start refactoring the printer, we need to create an implementation of this printer queue. I'll create a simple class that I'm going to call simple FIFO printer queue or simple first in first out printer queue. I'll create a simple variable that I'm going to call queue, which is of type job, and we'll use one of the Java collection classes for that. Maybe something simple like linked list. We'll need an implementation for the add job method. Go to the queue and add the job. And for get next job, we could do something trivial like go to the queue and remove the element. The queue could be empty though, so we probably should first make sure that the queue is not empty and only then return the element that we removed. And if the queue is empty, we should return null. Come to think of it though, it would be simpler to use the pull on the queue, which has this exact implementation. The pull operation on the queue returns the first element or it returns null if there are no elements. Now that we have an implementation of a queue, we should be able to go back to the printer and refactor it to use this queue. So let's first introduce a variable that we're going to call the printer queue, which will hold an instance of a simple FIFO printer queue. I'll remove the jobs variable so I'll see where the errors pops up. I can obviously remove the construction of the jobs variable from the printer constructor. We see now that we remove the jobs variable that we've introduced a new set of errors, and we should go and attack those. To get next job, we could simply just go to the printer queue and get the next job from the printer queue. We can delete the remove job method as we have a new behavior for the printer queue that does that for us. And we can quickly refactor the algorithm for printing the job too. We could basically have the job returned from the printer queue. We could remove this. After we've done that, we can actually get rid of the get next job method also. And it seems my final error is in the print method where we need to change to use the printer queue. And that concludes the refactoring of the printer. This made the printer a little bit simpler, and we now have a implementation of a printer queue that has been separated from the printer, but is still hidden from the client. Well, let's make sure that the new printer works. So I'll go back to main and run that and see if we get the same result. And it looks identical to what we saw before. We get the jobs printed in the order that they were produced. One of the strengths of the strategy pattern is that it's now relatively easy to introduce a new queuing behavior for the printer. We can do so without affecting all the other implementation of the printer. And to do this, I'm going to make an extended example. Maybe what we do is we have a queuing strategy that is based on the priority of the jobs. To do so, I would have to add priority to the job so we have some chance of organizing the jobs based on priority. So I'll start by going into the job and adding the concept of a priority. I'll create a simple property called priority of type int, and I should probably give that a default priority of 50. We should probably introduce a method for grabbing the priority, so a getter for priority. And we should probably also introduce a constructor that allows the user to set the priority at construction time. We have two constructors already, so I'll duplicate them and create four constructors, one with priority and one without priority for the two constructors that we already have. So now jobs are allowed to have priority. Now we need to take that into account when we create the jobs and also when we print them. Let's start by creating a printer queue that understands priorities. I'll create a new one by copying the FIFO printer queue and simply call it job priority printer queue. I need to change the queue variable now to be of type priority queue. We don't really need to change the variable type. That could still be a queue since priority queue implements the queue interface. For the priority queue to work, we need to take into account the actual priority of the job. And the easiest way to do that would be to create a comparator that we pass on to the priority queue itself. So I'm going to create an anonymous in a class here that is of type comparator for jobs. And in the required compare method, I'm simply going to forward to the integers compare. And that should allow us to prioritize the jobs. Now, the priority queues should use this comparator and compare two jobs or put them in the order of the priority. Before we can test this out, we need to go back to main and inject the priority into the construction of jobs. So I'm just going to use the random and ask for the next int up to 100. So if we run it now, we should see that the jobs come in a different order, potentially from where they were created. We'd be extremely unlucky if we managed to print them in the correct order. Another thing we need to do is obviously to instantiate the priority queue inside the printer. So we'll do that real quick and replace the old simple FIFO printer queue with the job priority queue. Okay, let's run it and see what happens. Okay, so we go back and run the same example again. And let's take a look at the console. And we see now that the jobs come in what looks like random order. It's not random, obviously. It's based on whoever got the lowest priority. And that's exactly what we were aiming for, so that looks good. So we changed a single line in the printer implementation, and it changed the behavior of the printer queue. And notice that we now managed to separate out the concern of prioritizing the jobs and queuing the job into this so-called strategy, which we now call a printer queue. I could imagine breaking out other concerns also into strategies into the printer. Maybe the translation from the content string into a printer language could be a strategy. Maybe the notification or the way we notify our users could be a strategy, and so on. But I'll just stick to this simple printer queue because I want to illustrate a couple of other issues with strategy using that example. One common concern is who creates the strategy. In some cases, we might want to let the client define the strategy. That is, we want the client to instantiate a strategy for queuing and pass it on to the printer so the printer is totally unaware of the various implementations of the strategy of queuing. So what we could have done is we could refactor the printer so that the printer allowed for a constructor where a strategy could be passed in. We could have the queue strategy being passed into the constructor. I'll leave the old constructor and let that create the simple FIFO printer queue. And I'll implement the second constructor that allows the client to pass on the queue strategy. Let's just fix the variables. Let's comment out the printer queue. Well, we need to introduce the empty printer queue. So that should do it. If we run it without changes to main, we should see the simple FIFO print queue take effect. And it looks like that is working just fine. But now we can go back to the main method and let the client introduce a strategy. And we can have the client introduce the job priority printer queue. And if we run it again, we should now see that the client controlled the printer queue, and we're now getting jobs printed out in priority order. Now, in many cases, letting the client instantiate the strategy and passing it on may be too much. We may want to control the implementations within the printer hierarchy. But we can still use this implementation method, like called strategy, and give the client some freedom to define what queuing strategy to use, but perhaps control that by using something like an enum. So let me show you an example of that. What I'll do is I'll go to the printer class and I'm going to introduce an enum, which I'm going to call a queue strategy that has two values, FIFO and job priority. And this is the only thing that I'm going to expose to the client. Instead of having the client passing on an object, what I'm going to have them do is to pass on an enum value that specify which one of the queuing strategies they want me to use. With that, I can control how these enum values map onto underlying implementations. So now I can still have the queuing implementation controlled by the printer hierarchy and hidden from the clients, and just make a simple abstraction to the client where they're allowed to pass on one of these enums that maps onto one of the underlying implementations. while I'm in here, I should probably also fix the default constructor and take advantage of the mapping that now occurs in the constructor that takes an enum. Notice that we now still allow the client to control which queuing strategy we use, but they have a much looser coupling to the actual implementations of strategies, which in some cases can be much more desirable. I'll just quickly fix main here so that it uses the enum rather than instantiated strategies. And let's also run it to make sure I didn't do any mistakes. So if I execute it, we should now see that we picked the job priority, and that looks good. We see the order is based on priority, not in the order that they were received. And I could, of course, also change this back to FIFO and then run it again and make sure that it works that way too. And that looks also good. Clients were able to select what strategy we should use for queuing, but we kind of hidden the mapping of that to the underlying implementation. Sometimes that's desirable, sometimes not. Then there could be different variations. It could, for instance, be that the printer changed the strategy itself based on, say, time of day. Maybe we have a different strategy during night where we do the longer jobs, and during day we pick the smaller jobs first. And that could be entirely hidden within the printer. And maybe our only goal for the strategy was to be able to separate out that concern to clean up our implementation.